Welcome to the project demonstration of battery management system with SOC and SOH calculation by using PIC microcontroller. So we are using battery management system will be done through the voltage sensor and charging circuits through this electromagnetic relay, and parallelly we are going to calculate the state of charging and state of health SOC and SOH. So while we are charging the battery, we will calculate the state of charging in such a way using the Coulomb counting method. So means how much of battery is charging in the 10 seconds of duration or 20 seconds of duration, and based on that we are going to calculate the SOC percentage. If it is charging in a proper way, then the system will display the SOC as 100%, and if it is not properly charging in 10 seconds, for example in 10 seconds it has to increase 0.1%, so then it will considering as a normal battery. Otherwise it's going to be the near to the dead battery, then the SOC values will be decreases. Same for SOH also. So SOH nothing but after the battery is getting fully charged, then it will calculate the discharging ratio also. If it is fastly discharging, then the values will be displayed on this LCD screen, which is acting as a SOH values. So we are using a temperature sensor continuously monitor the temperature of this battery pack. So when the temperature is high than the threshold value, then automatically the system will on this buzzer to provide the audible alert. And also on LCD display we can see the battery voltage levels and SOC, SOH and temperature. So coming to the components, so we are using 230 volts input to this transformer, so which will step down the 230 volts AC to 12 volts of AC, and this regulated power supply board will convert that into 12 volts of DC, so which is a charging voltage for the battery pack through this electromagnetic relay, which is acting as a switch between the 12 volts DC and battery pack. And our operating voltage of our microcontroller is 5 volts. For that purpose we are making use of this 7805 regulator, which will take 12 volts DC inputs and provide us the 5 volts DC output. So once we get the voltage to this microcontroller, it will start reading input from the temperature sensor. We have interfaced that at the A0 pin, and A1 for the voltage sensor. So we are using two resistors which will acting as a potential divider. Why? Because we need to measure the voltage of this battery pack. So this is a battery pack of 12 volt 1 amp. In this battery pack we can see the 4 volt 1 amp batteries are in series, so we will get 12 volt 1 amp DC output, but the operating voltage of our microcontroller is 5 volts. So in order to make it less than the 5 volt, we are using 10:1 potential divider ratio. Here when the microcontroller getting 1.2 volts output from this voltage sensor, the input is 1.2 into 10, so 12 volts. So that will be calculated inside the microcontroller using the embedded C programming language, and the status displayed on the LCD screen, which was interfaced at the pin number B2 to B7, and buzzer at pin number C4 and C7 for the electromagnetic relay. So let us see the demonstration. So once we switch on the kit, a welcome message will displayed on the LCD screen. So as of now we are using the low battery voltage, actually it's 12 volts, but here you can see the battery voltage is displaying 8.5 because already low voltage battery. So when this relay getting switched on, so it is charging the battery and off that to measure the proper voltage. So it's continuous process till the battery is getting the sufficient voltage. We can see the slightly the voltage is increasing here, and the second is at 27 degrees. So whenever the temperature increases, so when it crosses the 40, right, when it's 45 degrees centigrade, then we can get the audible alerts from this buzzer as indication of the battery is overheating. And SOC, SOH values will be calculated after 10 to 15 seconds of duration. We will get that. Right. So you can see the SOH's battery is charging sufficient voltage, so it's showing that 100%, and SOH is very fastly discharging, so it's going to 0. So let us keep the battery for around half to 1 hour time duration. When it is fully charged, we can get the SOH values also.